Okay, when factoring out a greatest common factor, we need to look at both the numbers and the variables involved. So if we look at just the number part first, we know that 45, 30, and 5 are all divisible by 5, and that has to be the greatest common factor since 5 is included in this. So 5 will pull out to the outside. Now if we look at the variables, we've got a to the 10th, a to the 6th, and a squared. Your smallest exponent is going to be what's common with all three. So we'll pull out an a squared. And then we're writing what's left over. So you can think 45 divided by 5 gives you 9. We had a to the 10th. We took out a squared, so that means a to the 8th. So following that same logic, I've got 6a to the 4th left here, and then just minus 1. You do have to include a negative 1 here. It's like a placeholder. All right, next one. So looking at the numbers first, 2 is going to be our greatest common factor. And then if we look at the variables, all three of those terms have an x in them. And then if you write what's left over, we would have a 9x squared minus x minus 9. And I should say you can always double check yourself by distributing back. And so we would get an 18x cubed minus 2x squared minus 18x. So that confirms that you would end up back where you started. Okay, so we've got some step-by-step directions, and if you need to jot these down, please feel free to pause and go ahead and write them down, but I will try to talk you through them as we go. So all these trinomials are presented to you in standard form, which would be ax squared plus bx plus c. So we are looking for factors of c that add up to b. And we're looking for factors of c because this a is just 1 here. So I know most of us know that usually you need to multiply a times c, and you can still do that, but when a is 1, we're taking 1 times c, which is just c. So we're really looking for factors of c. So on our first one, we want factors of 56 that add up to be 15. Well, hopefully you come up with 7 and 8. So you're going to factor this into two binomials. X's go here. And we want 7 and 8. So we need to determine the signs on this, and we call this a sign pattern. So here's what we do. We look at the last sign. If it's positive, which ours is, then you refer to the first sign for what signs you use. So these are both plus signs. Okay, so let's check out the next one. We want factors of 20 that add up to be negative 9. So if you want to, you could start with your binomials here. We know we have to have x's. If we trace our signs here, we've got a positive sign that tells us both of them need to be negative. So factors of 20 that add up to be negative 9 would be negative 4 and negative 5. Okay, and you could double check yourself. Negative 4 times negative 5 gives you positive 20. Negative 4 plus negative 5 gives you negative 9. Last one. So we want factors of negative 30 that add up to be positive 1. So I'm going to start with my binomials. And I'm going to look at my sign pattern here. So I've got a negative sign. This means my signs are different. One is going to be positive, one is going to be negative. So factors of 30 that add up to be 1, I'm going to say positive 6, negative 5. Okay, now we are talking the case where a is not 1. So when we're looking at standard form, it's important that you remember you have to take a times c. You want factors of a times c that add up to be b. Again, if you would like, you can write these steps down. It's kind of whatever you need. And I'm going to be showing you how to use a Punnett square. I know that many of you have other ways to factor, which is just fine. Just showing you a way that I know is tried and true and works every single time. So your first term, your ax squared term, always goes in the first box. Your c term always goes in the last box. These two boxes here are your two factors of AC that add up to be B. So here's how this works. We've got our first term in my first box, last term in the last box. So if we take A times C, or 12 times negative 15, we get negative 180. Just this time, I'm going to kind of make a factor tree because we need factors of negative 180 that have different signs, and I know that because there's a negative sign there, that add up to be positive 8. So I'm going to make a factor tree. I know 1 and 180, 2 and 90, 3 and 60, still too large here, 4 and 45, 5 and 36, getting closer, 6 and 30, 9 and 20, 10 and 18. And I'm going to stop here. So if I make that 10 negative and keep the 18 positive, negative 10 plus 18 gives me 8, and negative 10 times 18 does give me that negative 180. So there's your two factors that we want. So we are essentially splitting the middle term. That's what this is called. We're splitting 8x into negative 10x plus 18x. So those are what go in your boxes down here. Okay, now we use a Punnett square just the way we always have. So in our first row, what's in common is a 2x, and then I'm going to forward think this. So 2x times what gives me 12x squared? Well, that would be 6x. 2x times negative 5 gives me a negative 10x. 6x times 3 gives me that 18x. So my answer then is 6x minus 5 times 2x plus 3. Okay, so before we do anything on this one, I have noticed that I do have a greatest common factor here, so I can pull out a 2. I'm left with x squared plus 5x plus 6, which we really don't even need a Punnett square for this since our a value is now 1. So keep the 2 on the outside, put in our x's, check out our signs. So this means we need the same sign. They're both positive. So we want factors of 6 that add up to be 5. So that would be 2 times 3 would be 6. And 2 plus 3 gives you 5. So there's your answer for this one. Okay, we do not have a greatest common factor on this one. So we want to take a times c. So we want factors of 36 that add up to be 13. Well, 9 times 4 gives you 36. And again, I know that I want the same sign. They both need to be positive. So in my box, or in my Punnett square, goes 6x squared and a 6 down here. We're splitting that 13x into 9x plus 4x. So that's what goes in my boxes down here. Common factor within that first row would be 3x. So I'm missing a 2x here in order to get a product of 6x squared. 2x times 2 would give me 4x, and 2 times 3 would give me 6. So my final answer here is 2x plus 3 times the quantity of 3x plus 2. Okay, now we're factoring with difference of squares. And here's kind of some step-by-step steps for you. First thing, check for any common factors. And then we need to confirm we actually have difference of squares. So difference implying subtraction. And then you also need perfect squares in both your ax squared term and your c term. Eventually you need to be able to just recognize these, but I will show you with the first couple here that you can use a Punnett square if you weren't to recognize it. So with the first one, we've got a 4x squared. I'll put that in the first box, and a negative 25 down here. So we don't have any common factors, and we've confirmed that these are both perfect squares. So I'm going to proceed like we didn't catch that. So what we would want to do is take a times c. So we would want factors of negative 100 that add up to be your middle term. Well, your middle term is 0x. So your factors would be 10 and negative 10. So, and I'll put x's with those. So we've got a 10x and a negative 10x. So if you were to factor out common factors of that first row, we'd get a 2x, which means we need 2x here. And we need negative 5 and positive 5. So this factors into 2x plus 5, 2x minus 5. Okay. On the second problem, we do have a common factor this time of 2, so I'm going to pull a 2 out, and we're left with 16x squared minus 49. If you recognize that these are perfect squares, you can jump straight to the end. You've got a 2 on the outside, factors into two binomials, one with a plus sign, one with a minus sign. You're taking the square root of each part, so square root of 16x squared is 4x. Those go in the first two spots. Square root of 49 is 7, and you're done there. If you didn't recognize that, let me show you how the Punnett square works. So you would put your 16x squared up here, negative 49 down here, and again you would want to do a times c, so 16 times negative 49, which is negative 784. And your factors that add up to be your middle term, which would be 0, would be positive 28 and negative 28. So positive 28, negative 28. And again, we're pulling out common factors. So you would still get there the same way.